Okay, if you're looking for reducing or simplifying a radical, the following four conditions have to be true. Okay, the first is that no factor of the number of the base can have an exponent greater than or equal to the index. Okay, so if you were to write your base as in exponential form, and no power can be greater than or equal to an index. So what that means is if you had something like the square root of x cubed, okay? The index is 2, the power is 3, so this does not meet this first condition, and you have to reduce it out. Okay? Number 2, no power inside. The radical can have a common factor with the index. Okay, so again, if we're looking at the square root of x to the, actually let's say the 6th root of x cubed. Okay, so the first condition's met, right? No power inside the radical is greater than or equal to the index. Okay, but this second condition is not. Okay? The power of 3 and the index of 6 have a common factor, so this would not be considered simplified. And just like this was not considered simplified. And we'll go through and I'll show you examples of how to simplify these in just a second. Okay, there's no radical in the denominator. Okay, so anytime you have a radical in the denominator, it would not be considered simplest form. So you have to get rid of all radicals from the denominator. And very similar to this, based on the properties we just talked about, you can't have a fraction inside your radical. And so if you had the square root of 3/5, once again, because this denominator can be separated, we can apply the rule square root of 3 over square root of 5. That would then break rule 3. So regardless, you cannot have a fraction inside your radical. Okay, so these are the three conditions that have to apply. When you work to make sure these conditions are met, the way that you would do that, and we'll start with just square roots, is, so in this particular sample, the index and power are equal. Okay? Rule 1 states they can't be. In order to simplify it, the easiest way, or the way that I explain it, is you look at your index. Okay? Your index is 2. How many groups of 2 can you remove from this power? How many groups of 2 can you remove from 2? One group of 2, right? So when you simplify that, you bring the base out to the power of however many groups you accounted for. So there's one group of 2, and then if you remove one group of 2, how many bases of x are left inside the radical? 0, right? Because you took one group of 2, so you took 2 out. They became x to the first, and so you're left with nothing inside. Okay, now, so your simplified form is x. And this doesn't tell the whole story. Okay, what you now have is you have to account for the rule that I just mentioned on the last slide, which is the nth root of a to the n is equal to a, or absolute value of a. anytime the index is an even number, you have to test the following. Test 1, or step, I'll call it letter, since I already have numbers up here. Can x be a negative number? So when you look at the original form, is it possible for x to be a negative number in this original form, this unknown? And remember that in an even index, your quantity inside the radical has to be non-negative. Right, ready? Would you agree or no?
Yeah.
Okay, so repeat. What do you agree with? Which was? So you can admit that you weren't following? Okay. Try to stay with it. I know it looks familiar. This is right where we're going to get to the stuff that students miss on their final. Okay? So hang with me. I know I had to talk a lot today, and I don't like doing that, but can x be a negative number? If you square a negative, does that still allow you to put that number under an even index radical? Yeah, a negative squared is a positive, so the square root of a positive number can work. Okay, so if this simplifies and x was a negative, is this simplified form guaranteed to yield a non-negative value? An even index has to yield non-negative. Would it yield it in this form with just writing x? No, right? Because if x was negative 1, you could still square negative 1 and then take the square root of that, but it's not going to equal negative 1. So what operation can we perform to this variable to guarantee that you have a non-negative value when you simplify this? Sarah? Good. So you have to put absolute values around it. So in testing this, we see in that particular case, we use this second example. So the square root of x squared is equal to absolute value of x. Okay, let's see what happens if we try the square root of x cubed. And so we're still not meeting this first condition. So we have an index of 2. How many groups of 2 can we remove from 3? 1. So that comes out as x to the first. With how many x's left inside the radical? One group of 2 is 2. 3 minus 2 leaves 1. Okay, so do we need absolute values around this x? Let's take a look. Can x be a negative number? Okay, so if we plug it in to start with, can we take a negative, cube it, and take the square root of that number? No, you can't even have a negative. So if x can't even be a negative, you don't even need to worry about the absolute values in this case. Because here, this x would be a negative in the simplified form, so would this, but this is impossible. So x can't even be a negative. You don't even need to worry about it. All right, let's take a look at this next example, x to the fourth. Again, it doesn't fit that first condition, and it doesn't fit the second condition. But in that first condition, how many groups of 2 can we remove from 4? So that comes out as x squared. Okay. Can we test this? Can x be a negative number in the original? Yeah, or a negative to the fourth is still a positive. Square root of positive exists. Okay. If x was negative, does this form guarantee that we have a non-negative value? Yeah, so do you need absolute values? No, it's already taken into consideration, right? It already accounts for the fact that that cannot be a negative. So you don't need absolute values on that one.